The world woke up to a flurry of headlines. China unveils supercritical CO2 turbine, steam era ends, Red 1. Another blared, energy revolution. China's new turbine to slash emissions costs. TV anchors spoke in urgent tones, marveling at what experts called the biggest leap in power generation since the steam engine. Social media flooded with videos of Chinese engineers celebrating next to massive humming machines. This was more than hype. China's scientific community had tested, and now revealed, the world's first commercial-scale supercritical CO2 turbine. News outlets replayed scenes from the unveiling, a gleaming white turbine spinning silently, not a wisp of steam in sight. The excitement was infectious and energy markets trembled. Global leaders scrambled for statements, investors buzzed with curiosity and alarm. Was this the end of steam, the technology that powered the world for nearly 2 centuries? The story was just beginning. Behind the headlines stood a new invention with the potential to power the world more efficiently, cleanly, and cheaply than ever before. Before supercritical CO2, there was steam. The Industrial Revolution began with fiery furnaces and boiling water. Steam engines drove trains, ships, and eventually, the massive generators inside power plants. For more than 150 years, steam turbines were the heart of the world's electricity. Steam turbines are everywhere. Coal, natural gas, nuclear, and even some renewable power plants use them. They work by heating water to create steam, which then spins giant blades connected to a generator. The spinning turbine makes electricity. It's a simple idea, but it changed the world. Yet steam power has always had limits. Steam turbines are big, heavy, and need lots of water. They're not very efficient, and they rely on fossil fuels that release greenhouse gases. The world has been searching for something better, faster, cleaner, and cheaper. Now, for the first time in centuries, steam's long reign faces a true challenger. China's supercritical CO2 turbine promises to rewrite the rules of power. Supercritical CO2 turbines sound like science fiction, but they're very real. The idea: replace water and steam with carbon dioxide under super high pressure and temperature. China has now turned this theory into a working commercial power plant. In late 2025, Chinese scientists and engineers announced a breakthrough. Their turbine used supercritical CO2 to generate electricity with record efficiency. This was not a lab test or a small prototype. It was a full-size unit ready to join the grid. Why is this a big deal? Supercritical CO2 can carry more energy than steam. It also works at lower temperatures and needs much smaller equipment. China's new turbine is compact, quiet, and powerful. It marks a new era in energy. With this invention, China sent a message to the world. The steam age is over, and the future of power has arrived. So, what exactly is supercritical CO2? It's carbon dioxide pushed beyond its critical point, about 31 degrees Celsius and 7.4 megapascals of pressure. At this state, CO2 acts both like a gas and a liquid. It flows easily and carries lots of heat. In a supercritical CO2 power plant, fuel heats the CO2 until it becomes supercritical. This hot pressurized CO2 is then sent through a turbine. The turbine spins at high speed, generating electricity. Afterward, the CO2 is cooled, compressed, and sent back to be heated again. The entire system is closed. Very little CO2 escapes. The plant uses less water and occupies far less space than a traditional steam power facility. The process is efficient, fast, and surprisingly quiet. This technology combines the best of both worlds, the power of a heat engine, with the compact size and efficiency of a gas system. It's a radical shift from the age-old world of steam. So, how does supercritical CO2 stack up against steam? Well, the differences are huge. First up, let's talk about efficiency. Supercritical CO2 turbines can actually reach thermal efficiencies of over 50%. Steam turbines, even the best ones out there, rarely go above 42%. That basically means you get more electricity from the same amount of fuel. Second, there's the cost. Supercritical CO2 turbines are smaller and lighter, and they need fewer materials and less space. Cooling systems use less water, and in many cases, none at all. This really cuts down on both construction and operating costs. Third, the environment. Traditional steam plants burn coal, gas, or oil, releasing carbon dioxide and other pollutants. Supercritical CO2 plants can use many fuels, but because of their higher efficiency, they emit less CO2 per unit of electricity. Some designs can even capture and reuse CO2, making them close to carbon neutral. So, the verdict? Supercritical CO2 turbines are faster, cleaner, and cheaper. For the first time, a real alternative to steam has arrived. Inside China's new power plants, the change is obvious. Gone are acres of pipes, tanks, and cooling towers. In their place, compact turbines, shining control rooms, and teams of engineers watching digital monitors. The air is quieter, cleaner, and cooler. Engineers test the turbines obsessively. They check temperatures, pressures, and vibration levels. Every reading is logged. Teams gather around monitors, looking for signs of wear or trouble. The supercritical CO2 whirs invisibly inside sturdy steel pipes. Power plant managers talk about the shift. "We used to worry about water shortages," says one. "Now our turbines use almost none." Workers train on new systems, learning to handle the different pressures and controls. The transition is challenging, but the excitement is real. Across the country, old steam plants begin their transformation. Some are retrofitted, others are replaced outright. The energy revolution is happening not in theory, but on the ground, one turbine at a time. News of China's breakthrough spread fast. Energy companies in Europe, America, and Asia watched with awe and concern. Governments called emergency meetings. Could their old steam plants soon be obsolete? Environmental groups cheered. A cleaner, more efficient way to make power could help meet climate goals. Stock prices for steam turbine manufacturers dipped. At international conferences, experts debated how quickly SCO2 could replace steam. Public reactions were mixed. Some feared job losses at old steam plants. Others worried about relying on Chinese technology. But most people hoped for cleaner air and cheaper electricity. China, for its part, welcomed competitors. "This is not just for China," said one official. "It's a gift to the world, a chance to build a cleaner future together." Supercritical CO2 turbines could reshape the global energy map. Countries without much water could finally build efficient power plants. Dense cities could house small, quiet generators instead of massive steam facilities. Even renewable energy projects, like concentrated solar power, might use SCO2 turbines to boost their output. Electricity could become cheaper and easier to produce almost anywhere. The need for dirty coal plants might fade, helping to slow climate change. New industries could emerge around the SCO2 supply chain, from engineering to maintenance. Of course, challenges remain. Building the first wave of SCO2 plants will cost money. Training workers and updating power grids will take time. But the potential rewards are huge. For many countries, the question is no longer if, but when, they will adopt this new technology. Imagine a world where smokestacks shrink and skies clear. Power plants become smaller, quieter, and nearly invisible. Energy becomes cheaper, more reliable, and cleaner. This is the promise of supercritical CO2 technology, and China's breakthrough has brought it within reach. The end of the steam age is not just a technical milestone, it's a symbol of human progress, of our ability to rethink, rebuild, and renew. As the world races to stop climate change and provide energy for all, inventions like the SCO2 turbine offer real hope. Tomorrow's energy challenges demand bold solutions. With every new turbine that spins, the world moves a step closer to a cleaner, brighter future. The age of steam may be ending, but the age of innovation has only just begun. The world is watching, and for the first time in a long time, the future of energy looks not just possible, but promising.